Alright guys, so I wanted to make a couple of examples to teach you about quadratic regression. Alright, now the first one is using methods that you already know, and actually so is the second one, but we'll go ahead and talk through both of them. Alright, so here's the first situation. We got a student that wants to model the path of a rock. Okay, and it tells us a couple of things. It says that the student is standing at the top of a vertical cliff at a height of 20 meters right there. So what that means is that when time is 0, the height is 20. So that's a very specific point that we know. All right. Then it says he starts counting the time at the instant he throws the rock at point A. Then he measures the time at which the rock is at eye level, which is at point B. So that's after it goes up, and then it comes back down again to point B. So that time is 3.26 seconds. That's pretty awesome if you can count that accurately. But anyway, so time is 3.26. The height again is 20. All right. Then the last thing it says is he measures the time at which the rock falls into the sea. And so that's time 4.8 seconds. So that would be 4.8, comma, and then that's hitting the ground, which is 0. So I've labeled those specific 3 points, A, B, and P. All right? So since I have specifically those 3 points, and I know that I'm looking for a quadratic, then I can do this. I can say, well, that means that if y equals at squared plus bt plus c, then I can put in these values. I can put these values in for x and y in the first equation. So I'll go 20 equals a times 0 squared plus b times 0 plus c. Then I can put the next one in. So I'm going to go 20, which is the y value, equals a times 3.26 squared plus b times 3.26 plus c. And then I can put in the last one, which is 0 equals a times 4.8 squared plus b times 4.8 plus c. Now, at first, you may say, well, yeah, now I just got a bunch of equations. But the reality is I now have 3 equations with a, b, c, 3 variables. And even though there's a squared there, the squared is on the constant, which means that I actually have a linear equation. And so you can use your simultaneous equation solver in your calculator. Now, I'm not going to go into that. If you need to know how to do that, then go ahead and look it up on your go ahead and look it up in a previous video or in your notes. But this is 3 equations and 3 variables, and so you should be able to solve that using your equation solver. And when you plug that in, you should be able to get that y is equal to negative 2.71 t squared plus 8.82t plus 20. And so when you solve, it should give you A, B, and C, just like that. So that's one way to do it, okay? That's using the simultaneous equation solver, okay? A system of equations. All right, but I also want to talk about a different way to do this, okay? So I'm going to go ahead and erase this. The other way is by actually putting those points into a table, right? So if we've got x and y, now the first way that we went through only works if you have exact points and all of those exact points are right on the line. Then you can get a perfect fit, all right? If you don't have the exact points, okay, then you can still do a quadratic regression, okay? So we're still going to put in those points. When x was 0, y was 20. When x was 3.26, y was 20 again. And then when x was 4.8, y was down to 0. And so here, if you have a whole bunch of different points and not all of them are actually on the line, you can do what's called a quadratic regression. And so what you do here is you go ahead and use what you learned in the video that you watched right before this. So I'd like for you to try that, see if you can put those numbers in for x and for y. Remember, you have to go to the tables and spreadsheets and you put it in. Put the x's here, you put the y's there. Go ahead. If you need to go back and look at your notes or look at that previous video, you can do that, all right? And go ahead and put it in. And hopefully, again, when you push enter and when it gives you the answer, you should get y equals negative 2.71 t squared plus 8.82t plus 20. And hopefully you get exactly the same answers you did last time. All right. Now, one question is that it asks you is to, actually that's it. All right, good. And so here's a second example. Now, this one is real life data, or as real as we get in a contrived math question from our textbook anyway. But so real life data, so probably not going to be perfect points. So that first example that we looked at where we created the 3 equations and worked with that, that's not going to work here. You can't just choose 3 random points and create the equations, because what that does is that makes sure that it goes through those 3 points. But it might not fit the other points very well. So you have to use here the quadratic regression. All right, so the first part, I'm not going to go through part A, because part A you learned in that first video. So you should go ahead and do that, and you should get a fairly decent quadratic graph. Okay, then you can go on to the second part B, which is pretty strong evidence that it's quadratic behavior. You should get a graph that looks something like that. So I mean, it'll be pretty obvious that it's supposed to be quadratic. Okay, from there you can use your graphing calculator to determine the model for the function. So go ahead and use the second method from the last question, which is the quadratic regression. Right, so go ahead and put in your x values for x in that first column and the y values for y in the second column. Once you've got all those in, you can go into your stat and do the quad regression, and hopefully you'll get something like this. That let's see, what's the y? C. So C is the concentration. C of t is equal to negative 0.374, and I'm going to round it off. T squared plus 4.563t plus 0.1211. So you should get something like that when you do your quadratic regression. All right, if you don't get that, go ahead, double check, make sure that you put in all the numbers correctly there. Okay, the next question is to comment on the choice of model by determining the coefficient of determination. That is the r squared value, which when you do the quadratic regression, the r squared should automatically show up in that list of things, right? It'll give you the equation, but then it gives you some other things down below. One of those things is the r squared, and that r squared is the coefficient of determination, right? You should get something pretty close to 1, right? The closer it is to 1, the better the fit. It's kind of like your correlation coefficient when we were doing the linear graph, but it's a slightly different process. Okay, so as long as your r squared is getting close to 1, then we're happy with what we've got. Okay, the next question is to search the model function over the scatter plot and comment on the closeness of the fit. To sketch the model and comment on the closeness. So you should then be able to kind of draw your picture, and you can do this on your calculator if you want. One of those videos that you watched before taught you how to put the scatter plot on your calculator. So you should be able to just then add in a y1 or y2 equals this function here, and it should then put the line that you just calculated right in the middle of your scatter plot. You should be able to talk about how well it fits there. All right. The next part, F, says, hence determine the time at which the medication is at its maximum effect. All right, well, maximum effect then should be the maximum concentration, we're going to assume. And so that's going to be this point right here, which is the vertex. Okay, now you should be able to get the vertex by, once you put this graph into your calculator, you should be able to go into your into where the analyze graph is, right? So go into analyze graph and choose the max, and that should allow you to get this point right here. If you have a hard time doing that, then let me know. That's something we did earlier this year, and I'm assuming that you guys remember how to get the maximum. But if you don't, let me know. I'll send you another video that helps you do that with some buttons on the calculator and things like that. All right, so that would be the maximum effect, whatever you get right there. All right. So you should have gotten about 6.1 hours Okay? Then the next question is, using the model function, determine the time at which the medication will have been fully absorbed by the patient. So fully absorbed means that the concentration is back to 0. All right, so we're assuming that we got 0, 0 here. Okay, and so from the 0, 0, we now need to find where it crosses, because at that point in time, then the concentration will be back to 0 and the medication will be totally absorbed by the patient. So go ahead and calculate that. You can use the x-intercept, right? You can put 0 in for y and you should be able to calculate for that. Or you can get the zeros. You can get the zeros. You can put in zeros in that, go into your analyze graph and find the zeros, and you should be able to get both zeros there. This one we already know is basically 0, 0, but you should be able to get this one, which should be about 12.2 hours. Okay? And then the last question is, use the model to determine the concentration of the medication after 24 hours. Okay? Well, if after 12.2 hours it's all collected, that means after 24 hours, then the answer should be 0. And that's it. That finishes off the question for you. So this is all going to be about practicing the use of what you got in that other video, which is the quadratic regression, and then answering various different questions like what we just did right there with respect to that. All right, so let me know if you get stuck on any of them. Hopefully that kind of summarizes everything, and the videos with the calculator give you enough that you should be able to answer the questions. All right, that's it.